So now we will discuss kinematics of circular motion. I mean, kinematics means we have to discuss those equations with the help of which we can solve the problem of circular motion. And those equations. I mean, as they are given in linear motion, that v is equal to what? V is equal to what? U plus at. Then s is equal to what? S is equal to ut plus half at square, and then your v square is equal to what? U square plus 2as. Now exactly similar to that. Now here v, I mean, u is your initial velocity, v is your final velocity, a is your acceleration, s is your distance traveled, and t is your time. So those quantities will be changed. Those quantities will be changed in circular motion. I mean, u will become, say, u naught, initial angular velocity. B will become omega, angular velocity. A will become angular acceleration alpha. Distance travel will become theta. And t is what? Is a time taken. Okay, now just change those equations and write them. So the first equation will be what? Omega will be equal to what? Omega naught plus alpha t, and then second equation will be equal to what? Theta is equal to omega naught t plus half alpha t square, and the third equation omega square will be equal to what? Omega naught square plus twice alpha theta. So these are the three equations of circular motion. Now in differential calculus also we can express those equations. I mean the quantities of circular motion. So for example, your angular velocity normally it is written as what? Theta by t, but in case of differential calculus it can be written as what? It can be written as what? D theta by what? dt. I mean similarly your alpha will be equal to what? D omega by dt, or omega d theta by dt. So we can write down angular acceleration as double differentiation of theta, that is angular displacement with respect to time. So d2 theta dt square is double differentiation of theta. Okay, now some other important formulas relating circular motion to the linear motion. They are actually linear velocity v is actually related to your angular velocity by an equation, that is what? V is equal to r omega. V is your linear velocity, omega is your angular velocity, r is your actually what? R is for radius. I mean radius of the path in which the particle will move, and then a, that is linear acceleration, that is also related to angular acceleration by the same form, that is multiplying by r. Now in vector form, if we write those, v and r, so v will be equal to what? Omega cross r, and your a will be equal to what? In vector form, that will be equal to what? Alpha cross r. And don't confuse, because in the earlier discussion we have discussed that theta, alpha, omega, the angular displacement, angular velocity, angular acceleration, they can be regarded as vector quantity. So next we will try to prove these two expressions. So